books, or ideas, what you consume influences who you become. On the Mind and Matter podcast, we learn together from the best scientists and thinkers alive today about how your mind-body reacts to what you feed it. Before starting Mind and Matter, I spent 10 years in academia doing scientific research. I got a PhD in neuroscience where I focused on neuroendocrinology and the neurobiology of behavior, and before that, I specialized in molecular, developmental, and evolutionary genetics. I use my scientific background to help parse and translate the information that guests share on the podcast. In addition to the podcast, I write long-form written content inspired by the show where I integrate what I've learned across episodes. I also have a free weekly newsletter where I provide you with upcoming guests, share links, and provide commentary on scientific studies and research that I'm reading, and more. Visit mindandmatter.substack.com to find all of my content. The full version of this episode is available to paid subscribers at the Mind and Matter Substack at mindandmatter.substack.com. The full version is also freely available on my YouTube page. Just look up Mind and Matter or my name, Nick Jikomes, on YouTube, and you'll find the episode there. This is a partial version of the episode, and so it'll cut off partway through, but you'll still get a significant portion. So sign up to become a paid subscriber at Substack or visit my YouTube page to get the full episode. This is my first Ask Me Anything style recording. So I have a bunch of questions here I've compiled over the last few weeks from listeners. I'm going to go through these one at a time and answer most of them, all the reasonable ones. I prioritized questions from paid subscribers, but I have a bunch of questions from other people as well. Some of you sent these on social media. Some of you sent them through the website. I am going off the cuff here, so I don't really have anything prepared. I kind of put them in a vague order. The beginning questions are a little more general, focused on me and the podcast, how I do the podcast, how I select guests, a little bit more about me and things like that. And there's a variety of other questions here. It is Ask Me Anything after all, so I got quite a variety. The first part of this I'll make available to everyone, and the full version of this will be available to paid subscribers on my Substack. As always, as with my other content that occasionally goes behind a paywall, if you can't afford a paid subscription, just sign up for the free weekly newsletter at the Mind and Matter Substack. Shoot me an email and let me know, and I'll give you one for free. Okay, so I'm going to go through these one at a time. First question. Can you describe your educational and professional background in depth? What do you think drew you to your interests? What led you to start this podcast? Okay. So, on my Substack and a little bit on the podcast, you hear something about my background. So most people listening or that have listened to the podcast probably know that I have a science background, but you might not know much more than that. So I'll just give you, I guess, a brief-ish overview, and I'll start chronologically. When I was a child, I was always very much drawn to biology and nature. I think when I was a kid, I wanted to be a biologist or maybe like a wildlife filmmaker or something like that. I was obsessed with animals and watching them and, trying to figure out why they did what they did. I was obsessed with nature documentaries as a child. I used to watch, back when Discovery Channel was good in the days of my youth, I used to watch a show called Wild Discovery. I believe that came on every week. I watched every single episode. I used to tape it on VHS tapes before DVDs were a thing. And I used to watch the shows over and over again. So I was always interested in biology and nature. Eventually, obviously, I went to college at some point. So I went to the University of Wisconsin-Madison. By the time I was going into college, I didn't know what I wanted to study in college for my major. I was interested in everything. I was interested in biology and science stuff, but also economics and history. I was interested in philosophy and psychology. I really didn't know what I was going to study for sure, but I was very interested in science. And in my second semester of my first year at the University of Wisconsin, I actually started working in the lab of a very famous evolutionary biologist named Sean B. Carroll. He's actually been on he's been on 2 episodes of the podcast, so you can go check those out. And I had read one of his books, and it got me really interested in evolutionary biology from the perspective of genetics and molecular biology and developmental biology, how animals were constructed and how the process of constructing an animal development could be changed to generate, evolutionary change. college. So I started working and pretty much just fell in love with that right away. So I pretty much transitioned to studying biology in college. So I majored in neuroscience, I majored in genetics, and also zoology. So I did all three of those for my coursework, and I worked in Sean's lab for 4.5 years, every semester and full time over the summer. So he was an HHMI investigator. They had these like fellowship style things for undergraduates, so I could work full time in the lab, make a little bit of money. And so I got a lot of research experience, and I fell in love with experimental laboratory science. His lab studied evolutionary developmental biology. So this is a subfield of evolutionary biology, which is very much influenced by molecular biology and developmental genetics. And so broadly, the lab is basically looking at how alterations in genes that control the process of development lead to phenotypic change in evolution. So how do new forms get built by tweaking the process of development? If you're interested in evolutionary developmental biology, where new things come from over the process of evolution, and what the real molecular developmental mechanisms are that generate that evolutionary novelty, that's really what that field and that lab have been concerned with. Sean has written a number of really interesting books. The one that I read that got me really interested in that work was called Endless Forms Most Beautiful. So that's by Sean B. Carroll, not Sean M. Carroll, the physicist. Really cool book, lots of vivid imagery, pictures, and really cool science there. So yeah, that was my research focus in college, heavy on the molecular genetic stuff. But I was also interested in neuroscience and behavior. I was always interested in animal behavior, as I mentioned. So naturally, I got interested in the brain through my interest in biology and animal behavior, but also my interest in philosophy of mind and consciousness and things like that. And so long story short, I ended up going into a PhD program in neuroscience immediately after college at Harvard University. I worked in a systems neuroscience lab at the Harvard Medical Campus. It was actually a systems neuroscience lab. So we studied mice, awake behaving mice, right? So we're recording neurons, manipulating neurons in adult, freely moving, and other types of mice. So we're not doing molecular studies, really. We're not looking at things in a petri dish or a test tube. We're looking at animals moving around and looking at the brain literally and manipulating the brain literally while they move around and do stuff. So I used techniques like optogenetic, the use of light in certain ion channels that you can put into specific neurons and cell types in the brain. And you can use those to actually manipulate neural activity while animals are doing things. So for example, I was doing a lot of manipulations of something called AGRP neurons deep within the brain in the hypothalamus. These are neurons that basically control hunger and feeding behavior. So you turn on these neurons, animals will get hungry, look for food, and actually consume it, even if their bellies are full and they just got done eating. And so you can manipulate neurons like that to study things like what neural circuits are doing and how they relate to behavior. You can also image neurons and record neurons in different ways. So this was a lab that was using a lot of calcium imaging and related techniques. So filling certain cells in the brain with fluorescent compounds, which will literally emit fluorescent light when a neuron is active, and you can literally watch through a microscope which neurons are active and how active they are while animals are doing things. The work that I did and the work the lab did more generally had to do with how hunger systems in the brain work and how visual systems in the brain work. We were really interested in how different motivational states change how information is encoded in the brain. So for example, you can look at the same stimulus in the environment. You can point your eyeballs, say, at a plate of food. And when you're really, really hungry, that's going to have a different effect on you than if you eat a big meal and your stomach's full, right? If you're starving, the cheeseburger is going to look very appetizing and appealing. You're going to be very inclined to go and get that. You're going to be very sensitive to the sight and the smell of that food. This relates to how value is encoded by neurons in the brain. If something is very much wanted by you because you're hungry and it's food, it's going to have a high value, and it's going to be encoded somehow in the brain. And when you're full and you're not interested in that meal so much anymore, the same exact sensory stimulus now has a lower value. It has less motivational pull on you. And so neurons in your brain are now going to encode the same information in a different fashion. And so we were interested in those types of questions. I studied a lot of behavior in freely moving mice, looking at how hunger systems and the motivation to seek food when you're hungry relates to other motivations, like the motivation to escape a painful or threatening stimulus. And so, organisms constantly have to balance these things in real life, right? There's always potential for threats or predators to jump out at you in the environment. There's always the need to find food, especially if you're hungry, the need to find water, the need to find mates, and so on and so forth. And somehow the brain has to encode all of these things, and different circuits related to different motivations have to sort of be balanced and prioritized in some fashion in order to prioritize what the animal is doing at any given moment, given what the greatest needs are. So, if you've ever watched a nature documentary of, animals in the African savannah during the dry season, right? It's dry, they're starving, they're thirsty. In some cases, they might be on the brink of starvation or dehydration. And so, a wildebeest might walk up to the water and take a drink, even though it can see the crocodiles in the water because the drive for water is just so strong under those conditions. And the brain has to negotiate all of those trade-offs. And that lab, even though it was a neuroscience lab, it was housed inside of the Department of Diabetes, Endocrinology, and Metabolism at the Beth Israel Deaconess Medical Center. So I was also, I was surrounded by a lot of endocrinologists and metabolism people studying things like gut hormones and insulin and, blood sugar and things like that. And then, of course, as a neuroscientist, I was focused a lot on the hypothalamus, which is really a neuroendocrine organ. And so a lot of my PhD work and education was in neuroendocrinology, effectively studying how the hypothalamus responds to and relates to the release of things like gut hormones, leptin, ghrelin, and so forth. Things that are related to hunger and satiety, things that are related to body fat levels, and whether the animal should be storing up energy or expending it to find food. And so I got a lot of really good education, not only in systems neuroscience and sort of the neuroscience of behavior, but also neuroendocrinology and the hormones that regulate the nervous system and other tissues in the body. What drew you to your interest? I think I've partly answered that. I was always interested in nature and in animals and how they work and why they behave the way they do. That sort of naturally led me to want to understand the diversity of animals through the lens of evolution. That was what I did in college, and then sort of the neuroscience, what's going on in the engine, so to speak, to control behavior. That was my PhD work in neuroscience. And you can imagine it's not a big leap from there to a lot of the things that I talk about on the podcast and discuss with people. Things like how different drugs affect perception and behavior, psychoactives, like psychedelics, pharmaceutical medications, and so forth. A lot about the neural basis of different forms of behavior, social behaviors, and feeding behaviors, everything that you hear me talk about. And then I've become even more interested in things like metabolism per se and the effects of hormones on the body. A lot of the diet and nutrition content that you see me talking about today sort of grew naturally out of my technical background. Yeah, but other than that, I'm just really following my interests and talking to people that I find interesting. How do you select guests? What do you think makes for an interesting conversation? Obviously, I talk mostly to like academic scientists and, physicians with a research background, those types of people, but other people as well. But the main way I select guests is I literally just email them. If you know how to do it, it's really easy to find, basically any scientist or researcher that you want. Their emails are easy to find through their papers and stuff. I know how to do that. And I just reach out to people if I see research that looks really interesting and well done. It's doing work that I find interesting. That's really who I reach out to. I don't have a lot of control over, obviously I have complete control over who I reach out to, who I send those emails to. I have no control over who responds to me, right? And so there's a lot of people that I reach out to that never respond or that can't do it or that are too busy that I would love to have on. Some people I've never heard of before. There's plenty of guests where I've never really heard of them before, but I stumble on their paper or I hear about it somewhere, looks interesting, and then I have them on, even though I've never heard them speak before. I don't have a lot of control over, how excited and enthusiastic the guests are, how verbose they are, how well spoken they are. There's, obviously some variability there. I think the number one thing is just picking people that are doing stuff that you find interesting, that I find interesting. And naturally, if you reach out to a scientist or a physician that's doing research, they're really interested in what they're putting all the research effort into. And they're typically, more often than not, happy and excited to talk about someone who's also excited about it. And another thing is just the most interesting conversations, I think, are with people that, are truly studying or writing about or working on what they are really interested in, what they're genuinely curious about, and being able to calibrate what you say to your level of knowledge and being able to express to whoever you're talking to that, I know a lot about this, I can go into detail, or I know a medium amount about this, but I'm not an expert in it, or I don't know very much about this, so take this with a grain of salt, or we should talk about this because I don't really know what I'm talking about. I think, being able to gauge that's a really good skill to have and to cultivate and to display for people. And a lot of guests are really good about doing that, some better than others. Yeah, and I think that's it. To some extent, you just can't control it. I think, I think guest speaks the most freely when they can tell that, this nothing is scripted here, and it's not. Obviously, I have some bullet points and some questions that I put together, but I let the conversations go wherever they may, and I try to keep it, natural and organic in that sense. And I think when people feel like it is, the conversation flows better, and they don't feel like they're being interviewed by a reporter with, a series of preconceived questions. And yeah, I think that's pretty much what I have to say about that. What are some of the most important things you've learned in your time hosting the podcast? Are there any insights that you wish the general public was more cognizant of? Well, yeah. There's definitely a lot I've learned. I mean, this is a science podcast, basically. Obviously, there's lots of facts and new results that I learn about and that I hope people take something away from in this. But I would say a bigger, I think I want to answer this in a little bit more of a bigger picture thing. Are there any sort of themes or things I'm picking up on and learning that sort of cut across all of the episodes, or at least many of the episodes? There's a few things I could say there. One, so I'm sort of the mindset that I think, a growing number of people are of, which is that we're living through a time of sort of cultural change and turmoil right now. Some would even say we're living through a time of civilizational decay. And a big part of that is that our institutions are rapidly changing. In many ways, they're in a sort of state of turmoil or decline. I think that includes things like media institutions. I think that includes things like the educational apparatus in the school system. And I think that includes things like our universities. And all of these things are hooked up to the government apparatus in different ways and to different degrees. And for all sorts of different reasons that I'm not going to necessarily spell out here, our institutions are really in a state of flux right now. Trust in them, has degraded quite a bit. The quality in many cases has degraded in terms of, the services they're actually providing for society. Basically, we spend more than ever on education, but we're worse than ever at it. Literacy and, math literacy rates are really lower than they pretty much have been in the modern era in our school systems, et cetera, et cetera. Within academia and what you might call the university industrial complex, very big name scientists have been basically caught having put out, a number of papers that are fraudulent or likely fraudulent. People at big name universities like Stanford have had to step down from very prestigious posts. There's replication crisis after replication crisis. Lots of papers now are verifiably being made either by AI systems, or they contain suspicious images that indicate fraudulent behavior. And one of the things I've learned is that while there's still a lot of really good science going on out there, and that's predominantly who I'm talking to, people that I think are doing interesting and good science, you can also start to detect a little bit where things get a little blurry and where people, aren't operating from a place of pure truth seeking and intellectual rigor. They're operating from a place of bureaucratic entanglement and being financially connected to different special interests. To give just one example of this, where I think it came out in the podcast, I'll give one example where I think it came out in the podcast from a research scientist, and then I'll give another example of a podcast that's more like about this topic. There was one podcast I did that I was super excited to do, I think last year, and it was with a scientist. I believe her name was Selena Wong, and the title is something like The Dirty Secret About Vegetable Oils. And I was really interested in this topic and really interested to talk to this person, because this was a chemist, a scientist at I forget which university, and she was basically doing a lot of analysis of vegetable oils and other food products, cooking oils and foods and things like that. And long story short, as some of you will know, but maybe not all of you, a lot of the vegetable and cooking oils that you can buy at the store are not what they say they are. Some of them are like, rancid. So it might be a bottle of olive oil that's made from rancid olives instead of fresh olives. A lot of these things are adulterated, partially or even completely. So you might buy a bottle of extra virgin olive oil, which has basically been spiked with some amount of soybean oil. And so, so this conversation I had with Selena, was going over her work, which was to actually pull the stuff off of store shelves and measure what's inside of it. And, literally measure, quantify exactly what's in all of these vegetable oil products. And that's important, right? Because now you can actually show that a large percentage of things are not what they claim to be. sometimes to a very large extent, sometimes to a medium, and sometimes to a small extent. And that's very useful, right? It would be very useful if then it would be a great public service if we could say, and here's what they are. Imagine how useful it would be if you could go to this work as a consumer and be like, I want to know which brands making vegetable oils, which ones are actually giving me what they say they're giving me, and which ones are hucksters. And so at some point in this conversation with Selena, I was like, okay, so you found all of these, vegetable oil brands that are giving people adulterated products or just products that are rancid or whatever. What are the brands that are good? What are the good brands out there that are selling what they say they are? And what are the bad actors out there that are really, really deceiving people? And she wouldn't tell me. And I said, why wouldn't you tell me that? Why wouldn't we share that with people? That's useful, and that is good for human health. We are helping people find things that are real, and that has real ramifications for your health, right? If I buy something that's olive oil, I want to know that I'm eating olive oil and not soybean oil. And she wouldn't tell me. And I said, well, why wouldn't you tell people that? And she said, well, me and the university just decided that it's not our job to police the industry. And I said, well, that's not policing the industry. That's just making available the data you have. Isn't that sort of like your duty as a scientist? And, basically she said, blah, blah, blah. It's not our duty to police the industry. And I'll let you guys go listen to that episode and interpret it for yourself. But the way that I interpreted that, the way that I read between the lines is that scientists like this are working at universities. They're bringing in grant money. And they're bringing in funding. When you talk about food science, the grant funding isn't purely just like NIH grants and things like that. A lot of this funding comes from private industry, including food companies, including vegetable oil companies. And so, my take on that conversation was that it was revealed through her words that there are financial entanglements whereby some of these cooking oil companies and other companies are probably injecting a solid amount of cash into the university system to fund research like this. And part of the quid pro quo there is that when the results might cast a negative light on the people providing the money, that their names will not be named. And I think that's what's going on. I think the university probably tells scientists like that, we're not going to name these people because we need these research dollars to keep coming in, especially if you want to, keep your lab funded and your prospects for tenure secure, et cetera, et cetera. That's my interpretation. I believe it's a plausible one, even though I can't prove it beyond a shadow of a doubt. But, the more that you, having come from academia, having had conversations like that, having studied the sociology and the psychology and the politics of academic science, I can tell you that those entanglements certainly are there. And for better or for worse, people can't just operate from a standpoint of pure, hardcore truth seeking and scientific curiosity. There are other considerations in mind. People have to pay their bills. They have to secure tenure. And for better or worse, there are all kinds of financial entanglements that go into this stuff. And so that's something that I would always be cautious of, always be wary of. There's no such thing as a pure truth seeker. There's no such thing as a purely objective, dispassionate scientist. We're all human. We all have motivations and emotions and career goals and all of the things that we all have. And that goes for scientists as well. And so I think you can see that come out if you kind of know how to read between the lines in some of the episodes. Another episode that's sort of about a related topic to that is an early episode I did with a scientist named Michael Eisen. And I'll just keep it brief. He's kind of famous / infamous in the scientific world. He has his own lab. He's a scientist, but he also runs a open access peer reviewed journal. So he's been a big advocate for open access journals. So instead of, paying privately run, highly profitable journals that charge, exorbitant fees for the research, he thinks sort of everyone should move to the open access model. So we talked about the scientific publishing industry and how sort of broken and corrupt it is. For those of you that don't know, the bigger scientific publishers, the people running things like Nature magazine and Cell Press and things like that, these are big businesses, highly profitable. Not an exaggeration to say that they sort of hold academics hostage. Scientists are not paid to review papers. This is basically a free service scientists willfully provide to journals out of a sense of duty, and also because, frankly, there's a lot of quid pro quo that happens there. If you know how to see that, you can find it. People, I can tell you for a fact, it's a lot easier to get your work published in the high impact, highly competitive, brand name journals if you have a first name basis relationship with the editors and you know them and you're constantly reviewing papers for them, right? You do this for me, I scratch your back, you scratch mine, stuff that happens. Certain papers don't get published because they're considered dangerous in different ways, not necessarily because the science isn't rigorous or good. You've seen this happen. You see this happens all the time, but you see this happen with highly politicized issues. So stuff to do with SARS-CoV-2 and the mRNA vaccines. If you follow that stuff at all, you may have watched episodes I've done with people like Alina Chan or Kevin McKernan or Alex Washburn. There's a lot of backdoor communication that happens, and whether or not something is published in the literature and published in the brand name journals is not purely a matter of merit and rigor and scientific prowess. There's a lot of politicking and social engineering that happens behind the scenes. So that episode with Michael Eisen, episode 17, I believe, that one is about scientific publishing, what's wrong with it, and sort of open access versus for-profit journals and all that stuff. That's sort of something that's sort of wrapped around my interest in science research. And you always have to keep in mind that, again, this is not a realm of pure objectivity. We should have ideals that we aspire to, but always remember that we're human beings here, all of us, even those of us with laboratories and PhDs and who are doing things that we think of as sort of objective and all about truth seeking. There's always more to it than that, and you always have to keep that in the back of your mind. Finally, how about some controversial or polemical ideas or theories that are worth considering? Yeah, to riff a little bit off what I just said, I think, there's quite a bit of corruption in science, just like there is in all human enterprises. And any time that you've got people competing for high status positions where a lot of resources are on the line, you're always going to have corruption. The level of corruption will be proportional to the level of status and the level of resources that are at stake. I'll share an idea with you that is an idea that I think is really interesting from a thinker that I would love to have on the podcast. There's a man at the University of Connecticut named Peter Turchin, and he has a field that he calls cryodynamics, which is, he's basically attempting to make the study of history more scientific and more quantitative. He's of the belief that there is some level of predictability to what happens in history, and you can actually predict certain things at a macro scale with some level of fidelity, not with perfect fidelity by any means, about history. And there's definitely a lot of his work reminds me of the phrase that history doesn't repeat, but it does rhyme. And there are certain sort of cycles that tend to be seen in human history. Civilizations are built, they flourish, they stagnate, and then they decline and eventually collapse. Every civilization dies at some point. And Turchin's the thing that really drew me to his ideas initially was just the startling realization that 10, 20 years ago, many years ago, he was making the prediction explicitly in his writings that the 2020s would be a decade of immense political turmoil for the U.S. This would culminate in political violence, potentially even outright civil war. Long story short, the concept I want to come here that comes from Turchin is elite overproduction. And he believes this is one of the key variables that he believes from his research drives the decline in quality that you see in late stage civilizations that's related to civilizational decline. Overproduction of elites is exactly what you see all over the place, including places like academia. Basically, 100 years ago, to get into university, it was a very small percentage of the population that did this. You used to, people that went to college at prestigious universities to get a college education, they used to, be able to read and write ancient Greek and Latin, and do, fairly advanced mathematics, and be very, very literate in all kinds of different ways to even be considered to go to college. And over time, what became the industry, the college industry, became so profitable that they wanted to funnel as many people as possible through that apparatus. And we all know where we're at today, where you're expected as an average citizen to go to college. We always say that you need, growing up, I was told you need to get a college degree if you're going to make yourself anything. Many professions to this day still require you to have a college degree to even apply before they'll even consider you, no matter what that college degree is. That it could be, they don't say, it sort of just matters that you have a college degree. Somehow this degree is this magical credential that's supposed to be a free ticket to a prosperous career. And this whole sort of university industrial complex just evolved to funnel as many students as possible with as high a tuition rates as possible through this apparatus, and it's become a wealth extraction mechanism. And we've produced more and more people with degrees competing for jobs. And so that's sort of what we're seeing the ramifications of today. Part of the reason I think some of the economic issues we have are related to this elite overproduction concept, to this production of people with credentials that all of whom believe they're entitled to these high level positions and high level careers and jobs. But there's just too many people competing for too few jobs, and this results in turmoil. I think this thesis of elite overproduction from Peter Turchin is very interesting. I think it can explain a lot, and I would highly recommend looking into it if you have the time. He's written books on this. He's written a book recently called The End of Times. It's very interesting. It's probably the one to go to because it summarizes all of his work up to this date. I've read parts of that one. The one that I've read in full is called War and Peace and War. And it gets into this idea of elite overproduction and other things and how that ties into civilizational cycles. The idea that, cycles inevitably decline and that the U.S. is in a state of civilizational decline. I think it's fair to call that a somewhat controversial topic. I think more and more people are of that mind today, but, Turchin's been making some of these bold predictions for years and decades now. And I think most people were calling him crazy when he was first saying, 20, 30 years ahead of time that we'd be in a state of potentially civil war. And, look at us now. Okay, next question. How do you stay up to date on the latest research and developments in your areas of interests? A lot. So I would say there's two or three related mechanisms there. One, I use social media in a way that reveals a lot of new research to me. So my social media platform that I spend the most time on. Hey everyone, I want to take just a minute to tell you about a really cool health monitoring device I've been using called Lumen. It's a handheld, pocket-sized device with a sleek design. The Lumen device measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs for energy. I use this device in the morning or before bed or after meals or after workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I needed to fast and how hard I needed to exercise to promote fat burning. Being able to track whether your body is burning fat versus carbs will help you figure out how your body responds to your lifestyle and whether or not your weight loss and fitness strategies are actually working. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. Their easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more and use the code MINDMATTER, MINDMATTER, to get 10% off your Lumen device today. That's on top of the site-wide sale they are currently running, and the Lumen device is eligible to be paid for with FSA and HSA health accounts. Check out the link in the episode description for more info. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure. And vitamin D is super important for the proper function of the immune system and for a variety of other things. So visit athleticgreens.com/mindandmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase.